In this episode,
How cynical.
I would absolutely have advised them the hybrid route.
With all the negative stuff on social media, it's still a battle.
One controller must control both the heat pump and the boiler.
You don't worry, Mrs. Miggins, just turn the spur off, run the boiler, job done.
I keep on saying balance, like the entire world's just an equilibrium.
Which again, the customer looks at it and they're going, doesn't look the best.
For me, and I know Graeme hates hybrids and he doesn't want to talk about them really, he doesn't want to be here actually.
Hi and welcome to another episode of Homeowners Q&A. I'm your host Mars, and today we are revisiting the topic of hybrid heating systems. With the release of the 2024 MCS guidelines, there's a lot to unpack about how these systems are designed, installed and optimized. Joining me today are Neil Sawers from Grant, Chris Higgs, a seasoned heat pump expert, Graeme Ross from Greystone Energy, Graeme Hendra, heat pump veteran and longtime friend of the show. Welcome everybody. But before we dive into today's episode, we'd like to take a moment to thank our sponsor, Grant. The Grant brand has been the cornerstone of the heating sector since 1978, helping homes stay warm efficiently across the UK, Ireland and beyond. From their headquarters in Wiltshire, Grant UK distributes a wide range of heating products including award-winning air-source heat pumps, innovative hybrid heating systems and HVO biofuel-compatible oil boilers. They also offer complementary solutions like hot water cylinders, underfloor heating, radiators and solar thermal systems. Grant's commitment to sustainability and customer support ensures they're not only delivering choice, but also guiding homeowners every step of the way on their journey to low-carbon heating. 2 months ago, we actually recorded an episode on hybrids. 2 days later, the new MCS guidelines came out, which is kind of typical in this industry. So I figured it would be a good time for us to actually revisit the topic and talk about things. But before we actually do get stuck into that, after the release of the last episode, I've actually spoken about hybrids in a couple of different episodes here and there. And I've received a lot of DMs, I've received a lot of messages, a lot of comments on the actual videos on YouTube, where people are saying that, are we championing hybrid systems? And the answer to that is no, I personally am not championing hybrid systems. The objective of this channel is to create an objective conversation. I don't think that having conversations that are completely binary, so it has to be a heat pump or it has to be a boiler, are particularly conducive towards efficiency, towards comfort, towards long-term sustainability. I just wanted to clear that before we actually get stuck in, because the objective of this show is to actually talk about the most sustainable ways to heat your homes. And that actually includes, if it does mean having to keep your boiler alongside your heat pump, then so be it. If it's going to keep your costs down and it's going to keep you warm, I think that's got to be the primary objective. So Neil, let's start with you. So the new 2024 guidelines that actually come out last year, can you just walk us through the key changes that were actually introduced as part of those guidelines?
There's lots of them. Some you could see the backward steps, some you could see as, we can see where they want to get to. So looking at this 55%, which I think we did know, we kind of guessed that that's where it was going to be. 55% of the total heat load must be met by the heat pump. How the controls are going to know what 55% looks like, we don't know, but we do know, if we draw our graphs, 55% of the heat load is roughly going to be about 90% of the annual energy demand in the property. Really all we're looking at is for the boiler to top up that last 10%, even although that might look like on paper 45% as a minimum or a maximum rather of the heat load of the property. One controller, which I think again we knew was going to happen, one controller must control both the heat pump and the boiler. But I think we've got to be take a step back in that and say the majority of boilers that are installed at the moment are fully modulating gas combi boilers. Probably 80% of the gas market is combi boilers that can modulate. And the heat pump controller doesn't have to connect into that modulation. All it does is looking for maybe a higher flow temperature and more sustained flow temperature to put the power through the pipe to the property. So when we say it's controlling the boiler, it's just basically putting an on-off signal to the boiler. Now, I dare say there will be boiler manufacturers out there who shall remain nameless, but one of the big 5 or 6 who will be looking at probably a more in-depth integration and how that could look like when fitting with their boiler. And this is where MCS, I think, is looking at it as well. In the retrofit market, there's something like 28 million boilers out there in the UK already existing. A great number to actually start selling heat pumps into and ramping up the heat pump sales. We wouldn't be able to say that let's say a Worcester or a Valent or a Viessmann heat pump can only be fitted with one of their own boilers. It's going to be a situation where a Grant heat pump could be fitted with a Worcester boiler or be fitted with a Valent boiler. The way that the MCS has been written is it allows for this. And certainly from PCDB's point of view, when we start making the applications, we'll be able to make applications for our heat pump with a generic boiler, which might be slightly less efficient on paper, but it will still allow for the consumer to put heat pump technology in without the capital costs. The backward step, and I'll shut up in a minute, the backward step, as far as I'm concerned, is bringing out the star rating again from the old heat emitter guide. It's like the dinosaurs were happy with that, but this is the 21st century. There must be a better way of telling the consumer how efficient the system should be.
So, Graeme, shortly after the guidelines came out, I saw a less than flattering post from yourself on LinkedIn. Now, it's obviously been a couple of months since that's happened and you've had time to digest it. What are your key takeaways from the new guidelines?
It's been written by someone who hasn't thought about it very much, and it is a shyster's paradise. I've looked at it, and I reckon you can make an absolute killing out of this. Basically, there's a load of holes in it. So what Neil said is correct. It's got to do 55% of the load. So average UK house, 10 kilowatts. Therefore, as long as you put in a heat pump that gives 5.5 kilowatts, that's fine. However, we're not going to measure how much the heat pump does, and it doesn't have to do hot water. So the heat pump doesn't actually have to work at all. So you put it in, you fill the paperwork in, you switch off the heat pump, and you take your money. And that is perfectly acceptable because that...
How cynical.
Sorry, they never ask people like me, cynical people like me, how it works. But you could, if you were a shyster, you could turn up, sling in a heat pump, see it in the back of your combi boiler, fill in the paperwork, get your dosh, do a runner. Mrs. Miggins says, look, this heat pump's not all that. You go, don't worry, Mrs. Miggins, just turn the spur off, run the boiler, job done. I'm not suggesting for a second that everyone's going to do that, but that is a possibility. No measurement, no actual... checking whether it's being done well. The thing that made my blood boil is this. MCS have their faults, but as I've mentioned many times before, if you want the grant, you have to go down the route, so fill in the paperwork and shut up. Up until this point, you would go onto the MCS database and you'd choose your heat pumps and you look at the efficiency of your heat pump that's published, and some are considerably better than ours. Than others, sorry. You would say, okay, I'm going to pick a Grant heat pump because it's one of the top 10. It's going to give me the best run cost compared to, System X, which is in the top 100. And what MCS have done in one strike through this process is just said, sod it, all heat pumps have got the same efficiency. And you go, you own the database, guys. You know that isn't true. And so now there is absolutely no incentive whatsoever to buy a better heat pump. Obviously, there is because you get a better run cost. But from an installer point of view, if I'm putting a run cost together using one of Neil's units, and then I decide to use some other unit, they have the same run cost, no matter what they do. The only thing that changes is the run cost with temperature. There is no advantage anymore in putting a decent heat pump in. Cheapest, nastiest unit you can get. Bosh it in on a couple of 22s, see it in under the boiler, get the dosh and leg it. I just think it's going to be like double glazing. But, whoever wrote it doesn't know what they're doing. Bless them. And it's there as an opportunity. So let's get out there and make some money.
Chris, you've obviously got a hybrid system. What Neil actually said about, the boiler having to carry the 10%, I think that kind of echoes because we've got a hybrid system too. And this is actually the first winter where we've truly tried to run it as a hybrid. So when the temperatures have dropped to the point where the air source heat pump becomes inefficient, we have switched over to the boiler to allow us to bridge that gap in terms of efficiency and running costs. So ours is probably slightly under 10%, maybe about 7% time that the actual boiler comes on. Does yours echo something similar, Chris?
Yeah, I mean, the way that we designed the system that's gone into my house is purely based on like a temperature cutoff. We knew that some of the radiators in the property, single panel, perhaps in a hallway, spare room, we're going to struggle at a 50 or 55 degree floor temperature. So they were going to need the higher temperatures. So the way that we calculated it is we said, right, when is the heat pump, going to run out of steam, run out of temperature to be able to get the house up to 21 degrees. And for us, it was about 1 degree outside. So all we've done is, nothing more complicated than said, mid-air heat pump at 1 degree, you're going to stop. and then boiler will fire. But all the while behind the scenes, the heat pump's the boiler is constantly doing domestic hot water. The big benefit there is that we didn't have to remove part of the downstairs for domestic hot water cylinder, and obviously we just got that on-demand domestic hot water all the time. One of the critical reasons that I went for a hybrid, and at the time, obviously I think I was running Freedom. I think Graeme might have still been running it. Either way, I was involved in the business, so I knew a man who could get me, cheap domestic hot water cylinders and cheap heat pumps. I had no reason to not go, fully heat pump. If any of my neighbours came to me and said, I want a heat pump, which route should I go? I would absolutely have advised them the hybrid route, because less disruption. You're still gonna offset a huge amount of your carbon emissions if you use it correctly. Picking up on one of Graham's points, and ultimately it gets them on the journey towards a heat pump, a full heat pump life, as opposed to just going, well, it's all or nothing.
Do you need help understanding your heat pump? Then pick up a copy of From Zero to Heat Pump Hero, an essential guide offering practical advice and basic instructions for new heat pump owners to maximize system efficiency. Available in print and on Kindle, link in the description. So Graeme, you guys obviously have installed a lot of hybrid systems up in Scotland. When you go to a property and you look at it, what actually prompts you to say to that homeowner, look, I think that your property would be best served by a hybrid system? What's the thought process behind that?
A lot of the time, I find the customers just at that point don't want to have the upheaval of upgrading all the heating system as well. You can either run it with the boiler, or you can ask the boiler to take over completely, or use the trivalent where you put your costs in and just let the controller decide what's the cheapest method to run the system. But we have sized the heat pump to cover the whole load of the property, which then allows them at a later stage to take the boiler out, upgrade the heating, and I've got a fully functioning heat pump only. And that's kind of the way that we do the hybrids. But I found them quite successful. We've got a couple that do the hot water cylinder as well. So we've just plate loaded it to do the hot water side. We've got a couple fitted on just with a combi boiler, and the heat pump just does the heating and allows the boiler to kick in for doing hot water.
I think that's a really brilliant point that you made there, Graeme. When you size a heat pump, you do it for 100% of the load, or what the 100% of what could be achieved once the customer takes out, starts doing improvements to the fabric, to the ventilation, and starts reducing the heat load. For me, and I know Graeme hates hybrids and he doesn't want to talk about them really, he doesn't want to be here actually. I would say that this is a stepping stone. It's a bridge. It's getting us from A to B. It's not going to be here forever. And if you look at our European cousins in the mainland, Belgium and Netherlands started off like us. We wanted utopia, and utopia looked like everyone have a heat pump and chuck the boiler out. It's not going to happen overnight. And they eventually worked that out themselves. And they've now been installing hybrids for many, many years. In fact, Belgium have said, I think they're saying by 2035, hybrids will stop, because they've been doing it for that long. The Netherlands is still incentivizing hybrids to be put in, but eventually that will come to an end. We're just at the beginning of the journey, and we've got to be looking at this as a bridge. How many of those 28 million homes currently in gas combis can we get part heated with free? And if take Graeme's cynicism away again, sorry, I'm having a pop at you today, Graeme. No, but take that amount away from it, that they're going to switch the heat pump off and put the boiler on, then I think we will get the numbers up. Might not get to 600,000, but we'll get the numbers up, and get the public talking about their heating system and getting emotionally involved with it.
It's public confidence as well, because I mean, with all the negative stuff on social media, it's still a battle.
I'm not totally against hybrids, and I actually think what you say is very valid. What I'm totally against is setting up a very odd regulation which is open to incredible levels of abuse. I don't know the regulation in Belgium or Holland. Weirdly, I've got a feeling I might have to learn that fairly soon. But I bet you it doesn't say that it's possible for you to put in a heat pump and then switch it off, which ours does. I mean, I'm not saying that everyone will do it, but it is a possibility under our badly drawn up bit of legislation. One of the things that I think no one's actually mentioned yet, and is very well worthwhile looking at, is We have this new design guide. It's very, very clear. It tells you can do hybrids. It tells you how it works. It's not perfect, but it gives you rules. But there is one massive piece of information missing. Nobody knows what the bus grant will be if you do a hybrid. Now, the naysayers are saying the bus grant will be zero, and the sort of yay sayers, if you will, are saying the bus grant will be the same. Nobody knows. Well, someone does, but it's not someone on this call. Let's just explore the idea that the grant will be zero. If the grant is zero, you don't have to do any MCS paperwork. You don't have to do paperwork. You just fit the unit. So why would you put all this extra maths and procedure in? What idiot is going to do that maths for nought and pounds? But at the moment, the cost of MCS, roughly according to installers, is between 1,000 and 1,500 quid of paperwork to do. So the bus would have to be £1,500 just to make it cost neutral. Whenever you mention it, people go, there won't be any grant. There is going to be a grant if you're going to do hybrid. It's the only thing I do know. I just don't know how much it's going to be. We've been looking at business cases of how this would work. If the bus grant was £7,500, then it's really, really cost effective to put a little heat pump in, connect it into your combi boiler, etc. You could do that for £0, zero cost. And it puts us in a slightly perverse situation that if you're changing your boiler, it might be cheaper to change your boiler and put a heat pump in at the same time because of the grant. So it will work, and I agree that in other countries they've done it with hybrids to get heat pumps to be popular. It works. It's not my dream. I want people to just have heat pumps, but I'm wrong. I've spent 15 years being wrong. Let's get them in, get them have a little do like Chris clearly knew what he was doing more than me. I just went for heat pump on day one, and I get it, and we will get there. And I think something Graeme said was very valid, because it's one of the things I hate about hybrids. Graeme sizes the heat pump to be big enough, so when that boiler breaks down, you don't have to buy another boiler to top up your heat pump. You can go, okay, we're done now. Let's rely on this kit we've got. If you're only putting baby heat pumps in, so you're relying on the boiler, when the boiler breaks, you have to put another boiler in. That is not a solution I like.
I think one of the things one thing that's probably worth mentioning is when I designed mine, picking up on Graham's point there, I specifically choose a heat pump that covered the full heat load of the property. The only reason we couldn't go full heat pump is A, domestic hot water cylinder, and B, we had a lack of temperature coming out of the unit. In theory, if we went R290 now, then we'd get over the temperature issue, but we wouldn't get over the domestic hot water issue, so that would still need a cylinder. But the way that I like to think of approaching it is it's a phased approach. You get the heat pump that, if it's practical, is sized for 100% of the heat load, albeit you might not use it for 100% of the heat load. Then the following year, you upgrade some radiators, so then maybe you can use the heat pump to 100% of the heat load. And then the following year after that, you then get a domestic hot water cylinder, so then you can use it for the domestic hot water as well. And then finally, perhaps you decommission the boiler completely. But you sort of phase in the approach so that A, there's much less disruption, and B, it's cheaper as a sort of initial capital. It's not cheap, let's be honest, it's not going to be cheaper over the long term, because you're paying an installer to come back at least 3 times. But in terms of splitting that cost over a period, obviously it's going to hit your pocket less.
I said in the last podcast where we talked about hybrids, about having some kind of home improvement plan, and I think it needs to be legislated. Maybe that's too strong a word. There needs to be some connection between bus allowing some form of funding to the installer consumer to fit a hybrid system. But there needs to be an underpinning guarantee that over the next X years, the remaining life of the boiler, let's say, that there is an investment into the fabric, into the ventilation, into the pipework, into the infrastructure, into the rad sizes. And when you've done your design, you know that house, you know what needs to be done to actually allow it for a heat pump to be working on its own. And maybe it's, we'll give you this money up front to do this, but by the time that boiler fails, you're not replacing it. You're going to let that heat pump run 100% of the heat load. There needs to be some caveat there, or we're just going to be using taxpayers' money just to chuck in heat pumps that are not fit for purpose. And in another 10 years, Graeme's absolutely right. When the boiler breaks down, you're going to be replacing the boiler because it's cheaper than replacing the heat pump.
The installer I work for, their entire model is based around the changing in the mortgage laws, which come in 2028, I believe. I'm not an expert on finance, but I believe that rules change that in 2028 you won't be able to get a mortgage on a house with an EPC under a certain rating. So what you'll do is, as you buy the house, they'll lend you extra money, which you'll use to improve the house, therefore bring it back. The banks are obviously very keen on this because they're being legislated. So it's quite an interesting model. It's different from the model most of us work in of where we're working with energy companies or carbon. It's looking at the people who can really make a difference. You want to buy that house, you need 20 grand, you're going to have to put solar panels or a heat pump or so on in. Yeah, I hope that what you guys are hoping that what you've all said is true, is that people will do it properly. I hope they'll put the right size heat pumps in, and I hope that it will be a gradual transition to green heating system, just like it is with cars. A lot of people don't want an electric car, but they're going hybrid. It's doing a little bit, it's helping. I like the idea, what you say, Neil, but can you imagine the political fallout if Mrs. Miggins has just had a bill for 5 grand from the government asking for their bus back because she's just put a boiler in 2030? No politician's going to do that. It's just suicide.
But if you imagine with the clean heat market mechanism, which this year is going to start at 6% of fossil fuel boilers sold, you must sell 6% as heat pumps, or you get £500 fine. By the time 2035 comes, if they're going to increase it every year and it gets oil cent every year, and maybe we get back to where it originally started, which was £5,000 fine per heat pump that's not installed, against what, 60-70% of sales, it's actually cheaper for the boiler manufacturer not to make the boiler. It's not going to be that the customer can't buy a fossil fuel boiler in 2035. That's what the Labour government says. It's the fact that the manufacturers won't be producing them because they'll be fined if they do.
It's an interesting point. So the CHMM and this hybrid thing are totally linked together. It doesn't look it, but they're totally linked together. One of the things, again, when people shout about there won't be a bus. So let's well, there's not going to be a bus for putting a hybrid in. So you are a boiler manufacturer. Let's call you Grant. You are going to get fined if I put in a gas boiler, 500 quid if I put that in because you're not meeting your heat pump quota. But the MCS paperwork costs 1,500, so it's cheaper for Grant to pay the fine than it is for me to pay for the paperwork. You just go, forget it, I'm not going to bother. So again, where's the evidence there's going to be a grant? There is going to be a grant. These lads, I'm not suggesting it's Grant. I suggest there's a couple of other big.
Well, it's the fact that you can now put, well, you've always been able to put hybrids in the PCDB, but there's no automatic mechanism to do it. You've got to write to them and say, I want to attach this heat pump to this boiler. But going back to the MCS and the replacement of this template, performance estimate template, and we're going to talk about SPF and when it changed from SCOP, because it's still SCOP in the rest of the MCS documents and in the final certificate. Just a bit confusing for the consumer that there's no SCOP in the form now, it's SPF. And you can't get any more than 4. So you could be running an underfloor heating system up to 35 degrees, which according to the MCS stat, if you fitted a Grant heat pump, you might be around about 4.85 as an SCOP at 35 degrees. But on this form, I can't get any more than 4. Why is that?
It's like the hot water as well, though. I mean, they've still got the water at 1.75. A heat pump could still be at that temperature, producing that over 3, way over 3. Which again, the customer looks at it and they're going, doesn't look the best.
I can never get my head around how this stuff is written because I don't get involved in any of the discussions because, as I've mentioned before, I'm a dictator, not a team player. The idea that you take very, very flawed data and do more and more and more complicated maths on it in the vain hope that it will come out with an accurate answer. You go, the data's rubbish at the beginning. It's a guess. They could have done something much simpler and kind of gone, a heat pump is the same cost to run as a boiler if its SCOP is 3.2 or whatever. So go and ask Grant, what are they giving you? 3.8. Okay, cool. That's cheaper than a gas boiler. It could have been even a sliding ruler that says 10% cheaper, 20% cheaper. Really simple, but they're hiding behind flawed maths. We all know, we've discussed it in depth. The heat loss that we do at the beginning is massively flawed and very inaccurate, based on an enormous calculation, which is wrong because we don't really know what your house is made of. And that error is then carried the whole way through the process. And everyone's like, it's okay, guys, because we've got loads of paperwork, so it's perfect. And all it is giving you a grant with paperwork to back up. What they don't want, and I understand this, they don't want to give me £7,500 and then work out I'm a shyster. So they've got lots and lots of paperwork to prove I've done a process and everything's been done right.
You've ticked the boxes
Mm-hmm.
and you trust your EPC report implicitly.
My EPC said I had a heat pump and 300 mil of loft insulation before it went in, because I said to the lady who did it I was going to do that. She went, "Oh, I'll just put that on there."
That's sad.
One of the biggest points that homeowners raise when we talk about hybrid systems is that if you are in a mains gas area, you're then going to have to handle 2 standing charges and 2 sets of maintenance fees. So basically maintaining the heat pump and the boiler. So when you advise your neighbors to basically jump on board a hybrid system, is that something that you disclose to them?
No, I hide that completely. Yeah, no, no. I mean, you're quite right. Yeah, you are going to have double the standing charges. We've got to be careful not to look at my individual circumstances, but how the estate that I live on, there's 4.5, maybe 5,000 houses here, so it's a fairly decent market if someone wanted to go and put a load of heat pumps in. All the cookers, or the vast majority of cookers, are dual fuel. We've got gas and electric, so you're going to have unless you want to change out your cooker as well, you're going to be looking at continuing that gas supply. And the servicing side, again, yeah, a very, very good point. But if you marry that up against what a domestic hot water cylinder would have been to install, if you look at the whole commerciality of the difference in projects between hybrid system and full heat pump system, you can get a lot of boiler servicing done for what a domestic hot water cylinder would have been to install. So again, you've just got to look at the whole thing as a as a commercial proposal. What I would say is that there's an element of you're increasing the longevity of the boiler, whether that's right or wrong, let's forget the ethics for a minute, but in terms of the commerciality, you're using that boiler less, so you're going to be increasing the longevity of it. Yes, you still need to get it serviced annually, but actually in terms of breakdowns, in terms of spare parts, in theory you're going to need less. I keep on saying balance, like the entire world's just an equilibrium and everything needs analysing. I don't think it's ever as easy as going, we've got a standing charge, you've got to account for that, because actually you've got a standing charge, but then you're using the boiler less, so you're going to have less sort of reparation and maintenance on that. So how do we allow for that? There's a lot of vectors that we need to sort of take into account to make sure that we've got a proper view of what's of what the actual lifetime cost is going to be.
So Neil, at the outset of this episode, we spoke about, you certainly mentioned the single master controller for hybrid systems. We have got a hybrid system. We don't have a modulating boiler. So in an instance like that, if somebody doesn't have a modulating boiler, they've just got just the basic boiler that's actually running in their property, and they want to get a heat pump, does that mean that they would have to ultimately get that boiler replaced alongside the air source heat pump if they wanted to retain both?
Not necessarily. I mean, yeah, if you took an oil boiler, a typical oil boiler in the market, it's on off, the burner's on off, and there's no reason why that can't operate well. If the controls of the heat pump is looking for a specific target temperature based on some weather comp curve, the boiler might be set for 65, 70 degrees flow temperature. But as soon as the controller sees that mass has been, or not the mass, the flow temperature has been achieved, you've now got a mass of water inside the boiler jacket. Doesn't need to be heated anymore. It will switch the boiler off. It will use the latent heat within the boiler to continue to feed into the heating system for as long as the heating system needs. If it needs more, it will bring the burner back on. So it's not as sophisticated as modulation, but it still operates. It just takes slightly longer because there's a higher water volume content in the boiler.
Our boiler's got a little dial on it. So basically, I think you just adjust the actual flame. We've got an oil boiler, we're not on gas. And it's really interesting because we've tried to dial that back. So you just get to a point where that boiler just doesn't come on anymore. So ultimately what it's doing is it's still ramping that hot water up really, really high. The heat pump controller, as soon as it hits 45 degrees or 50 degrees, whatever it's set to, then cuts the boiler out. So it basically circulates that water, but that boiler cycles a lot.
It does. I think we're going to have a conversation soon about buffers and thermal stores and volumizers.
Next week.
I've got it in the diary. That's when the buffer comes into its own, because you could actually store that as a battery, not use the buffer as the main heat source to supplement the heat pump.
Planning to install an air source heat pump? Then get your copy of Bodge Buster. It's packed with must-ask questions, real homeowner insights, and a practical guide for a smoother installation. Available in print and on Kindle. Link in the description. we are speaking about hybrids, but there are a lot of high temperature heat pumps that are also entering the market now. So is it then potentially a more viable option for a lot of homeowners to say, okay, look, I'm concerned that my heat pump might not be able to heat my property? Is it then a more sensible choice for them to go, okay, let's consider high temperature heat pumps as opposed to going something that's, lower?
Is it this Graeme or the other?
Sorry, Graeme, Hendra.
Okay, sorry. Yeah, again, using the model that Chris used, which is to put a heat pump in, which was primarily designed that in the future it will be the only heating system, then it makes a lot of sense to buy a heat pump which can give you any temperature you like, and then you've got the choice. So if you do the dream job of changing all the radiators and running it all stone cold, which I despise, I like warm radiators, you can have cold radiators, you can have hot radiators, you have a choice. If you can even buy a heat pump anymore that runs at low temperature, I haven't seen one for ages, but if you buy a low temperature heat pump, then you haven't got that choice that you could run the radiators very warm. So, and that choice is dying a death. In 2 years' time, R32 is banned in heat pumps. So you're using R290. Get over yourselves. It will be a high temperature heat pump. The temperature you dial into it, your choice. You can then go, right, I'm not changing the rads, or I'm not changing them for a couple more years. So I'm going to run it at 50 or 60 with the associated increase in run cost, or I can change the rads and drop the run cost. And it is, and I very much get this idea. It took me a very, very long time to learn this. We are on a long journey here. So I come from the school, which was we come in with a hacksaw, we rip the whole house to bits, we charge you 25,000 quid, and we flog you a heat pump. And I was wrong. That isn't what the general public want. So this journey is important. It takes time. So I would suggest, as a homeowner, if I was having this done, and you were looking at hybrid, which is fine, I would say make sure your installer sizes it that it is big enough for the house. Secondly, make sure that the machine is capable of running those high temperatures should you need them. Probably don't, but should you need them, they're there.
Can I ask you a question on that, Graham? What do we do then? Because the rules are quite clear that the minimum requirement is that the heat pump needs to be able to do 55% of the load. What you're saying is the heat pump needs to do 100% of the load, but it doesn't need to run at that from day one.
Yes, so that is what the wording says, is that the heat pump you install must be. So let's go back to do the simple maths. 10 kilowatt house, the minimum size heat pump you're allowed to put in is a 5.5 kilowatt, but you can put in a 7 or an 8 or a 10 or a 23. Don't do 55. If you do 55, you're setting yourself up for buying a new boiler in the future. Which is which my whole reason for disliking hybrids is that, great, we're keeping the boiler lads in a job for even longer.
For the viewers, and it would be nice to think that some politicians and that some influential politicians will be watching this, that sit in DESNES, is that while we admire this 55% as a minimum, really, before you start handing out lots of money, taxpayers' money, to these shysters that are just going to throw in heat pumps left, right, and centre, is that we need them even in a hybrid system. If we can't get a heat pump put in that will meet 100% of the heat load today, then it will meet the heat load once the reparations have been done in the house, but not 55% of what currently exists, because I don't think it's enough.
Have you ever wondered why it's 55%? So you could argue 55% because the power supply to the house isn't very big, therefore 55% is what it is. But the number of houses that have a 20 kilowatt heat loss is tiny, in the big scheme of things. So 55% of the average, which is 10 kilowatts, just happens to be, well, pretty much a 6 kilowatt heat pump, the standard size, that the smallest that everybody does. And it's cheap and it's small and it runs on 22mm pipework and it's easy to put in. And there's no planning because it's dinky, it's quiet, so it's a rubbish solution to get rid of small heat pump. I'm totally with Neil. If they changed it to it must still be able to do 100% of the heat load, I'd be a lot happier. The fact that it doesn't is no good. Chris Higgs and I remember the bad old days of the MMSP, which the metering and monitoring something or other. It was horrid. You had to buy £1,000 meter made of solid gold and put it into your house and report the amount of energy each system was doing, because hybrids are not new, they were around years ago. And some shysters were making a killing on these heat meters because they were the only meters you could buy. And that was horrid. We don't want that. That isn't a great solution. But it does worry me that this idea that you are going to be able to put these little dinky heat pumps in and then not run them. Yeah, I know that's me being a cynical bastard, but I am a cynical bastard. I've been doing this a long time and I've sold some heat pumps. So has Chris, by the way, to some very unpleasant people over the years. Most installers are genuinely decent people doing a decent job, but there is a lot of people out there going, where is the angle? Where do I make my cash? And this thing has been written almost as if to go, there we go, guys, go make a killing.
So, Graeme, Ross, as we mentioned earlier, you fit a lot of hybrid systems. From your perspective, what do you think that manufacturers could do to improve their systems so that homeowners have a far simpler way of actually managing that hybrid system?
Really, it's all down to controls. You want a good control system. Some manufacturers are more basic than others, but you want something decent for the end user to be able to operate, to see information, and operation as well. That's the key features. Controls are getting a lot better as well. Like as we progress, you start looking at controls. You look at old heat pumps going back sort of like 15 years, and you're like, it's night and day now to what is available.
Neil, in terms of your controllers, is it quite easy to switch between? So, if, for example, you wanted to manually override the heat pump because it is just genuinely a lot colder today, is it quite easy to override and say, look, heat pump, go off for today. I just want the boiler to run today. Is it easy to do with your controllers?
It is easy to do, but I made the decision when we were designing it not to allow the either or situation unless there was a complete breakdown of the heat pump. So in that case, obviously you would just be left with the boiler. But yeah, very easy. You select it basically on the new bivalent point, whether that's because your radiators can't satisfy the heat loss based on the maximum flow temperature you got available, or you need more power, or you need hotter water going through. So because our heat pumps can take a 70-degree return, we just allow the boiler to come on at the same time as the heat pump. So it's supplementing what the heat pumps do.
I can't remember who it was that mentioned at the outset of this episode that you can run the heat pump in conjunction with the boiler, so they're both running at the same time, because that's happened to ours a lot. And I just assumed that it was kind of counterintuitive to what should actually be happening, because I didn't understand why the boiler is ramping up the temperature and why the heat pump's running at the same time at a far lower flow temperature. So is that common?
For grant systems it is. And I understand the counterintuitiveness argument, but what we found is if we just let the boiler take over, then there will be no requirement for the heat pump to start. And basically we want the heat pump to be running. And this stems back to the days of the RHI, when you were getting metered for a hybrid, is that you wanted the meter to be running. So you were producing energy with the heat pump, obviously not using the boiler's heat generation included in that calculation, but the heat pump was basically taking a warmer return, and it was easier to raise the temperature of a warmer return than it is a colder return.
If you have got a boiler of a different make and an installer comes through and he's got no clue as to how that boiler works, and he's there to try and put that hybrid system in, how do you train that workforce? As it is, there's a lot of cowboys out there that are just slinging these things. Is that just the recipe to have something that's even more of a fiasco in the making?
Yeah, it is. It is. I mean, I've always said, and please, the electricians that are listening to this, don't shoot me, but a domestic electrician who's not experienced in central heating systems finds it really difficult to work out series circuits. So you usually have a heating system electrician, and that's all they do. They do S plans, they do Y plans, they do W plans, day in, day out, and they eat it for breakfast. To actually say, and so many, like Grant oil boilers switch at 230 volts. I've got an ideal gas boiler at home, and it switches in 12 volts. And some boilers switch on 0 volts, there's passive volts, whatever it comes out, it needs to go back in. So the installer needs to understand how his controller works for the heat pump, and how to modify that, whether it's to the 230 volt switch, a passive switch, a 12 volt switch, whatever that is required. Because that's all he needs to do. He just needs to tell the boiler, you need to come on. That's all it needs to do. It doesn't need to do anything else.
Graeme, Ross, how do you guys get around that? You know, when you go to a property that has got a boiler and you guys want to install something that you may not necessarily be familiar with, is it a matter of doing research? Is it a matter of calling customer support? How do you tackle that?
I'm not on site now, so I don't care. We've gone through, in the beginning, sort of subcontracting electricians. 90% of issues, if something's not working right, it's on the electrical side. So we've made the choice now to bring in an electrician, and It's just getting them trained up, not 6 months to a year to get them up to speed of not just the heat pumps, but heat pumps, the solar, the batteries, comms. Once you've got that in place, you can kind of tackle most things.
Final word to you, Neil. So in terms of future iterations of the MCS guidelines, is there anything that you'd like to see kind of introduced or clarified or tidied up?
It needs to be consistent with everything else that's going on in the industry. I do appreciate, I used to sit on MCS working groups and the standards management group, and I spent years every week traveling to London to sit in another meeting to try and push industry forward. I appreciate what these guys are doing. They spend an awful lot of time doing it, and we can sit here in our ivory towers and throw stones at it. It is a hard job to do. It's even harder because they're not allowed to push their own agenda from their own business, their own company that's actually paying for them to be there. There just needs to be maybe more input from the likes of Graeme and Chris, and me. We need to be feeding that back in and actually saying, look, simple things like why you call it an SPF now when the rest of your documentation refers to a SCOP. PCDB refers to a SCOP. I know that HEMS and Future Home Standards, they'll refer to SCOPs. Why are you changing things and making it confusing? Let's be clear, let's be consistent, and let's simplify things again. Make it as simple as possible, because my God, the rest of the world's complicated in the heating industry anyway.
Have you got questions about heat pumps and renewables? Then head over to the forums at Renewable Heating Hub for practical advice from thousands of fellow homeowners and heat pump users. So that wraps up this episode of Homeowners Q&A, and a huge thank you to our brilliant panel, Neil, Graeme, and Chris, for sharing their expertise and insights on hybrid heating systems. We'd also like to extend a special thanks to Grant for sponsoring this episode. Their commitment to sustainability and homeowner support is helping shape the future of low-carbon heating in the UK. Thank you all for listening, and before you go, please give us a thumbs up, hit that subscribe button below, and as always, stay warm, stay green, stay tuned. Goodbye.